Hello everyone, welcome to the next lecture on the PY question series. Today, in this lecture, I will explain you how you can solve the problems related to the Cauchy equation. Myself, Dr. Harish Garg. You can follow my YouTube channel. The channel name is my Dr. Harish Garg, where you can find the various lectures on the CSIR net examinations. The objective of this lecture is we will cover the 45 plus questions related to the part B and part C on the topic Cauchy problem. I will explain you this lecture again with the help of the shortcut tricks. I hope you can subscribe my YouTube channel so that when I get uploaded my next video, you will get the notification. Now, whenever you are in the examination hall, try to look about all those questions which are related to the partial differential equation and it is of the linear form. That means which involvement only of the first derivative. Whenever you will see this kind of the equation, this is not a linear. So whatever the shortcut tricks I have explained you in this lecture, that is only applicable you for linear partial differential equation. Now whenever you have the linear partial differential equation, your first target is to write the Lagrange equation, that is a dx divided by p. What is the p? Is the coefficient of the del x, coefficient of the del z by del x. Similarly q and r. Make sure your this term r is on the right hand side. If it is put on the left hand side, you have to make into the right hand side. Once you can write this auxiliary equation, you can solve this equation by taking two equations at time. Then you will get the two solutions. I denoted the two solution as a u and v. These solutions are called as the characteristics equations or called as the base characteristics curve. Based on this solution, you can write the general solution of the linear differential equation or linear partial differential equation as phi of u comma v0 or one function as the other in terms of the other. Make sure your target is to find the value of the phi. What is the function phi? This is your target. And believe me, once you can watch this lecture till the end, you will know many shortcut tricks how you can find the value of phi in a very simple manner. Second problem is whenever you have a Cauchy problem, but is the some initial condition is given to you, then you have the two or three different choices. One is the unique solution, no solution, or infinite many solution. Remember this case, that means unique, infinite, and no solution is applicable only when the word on. Remember the word on is mentioned you in your problem. Whenever this word is not mentioned, then you always solve the problem with the help of the Lagrange equation. I will solve each question 45 plus question with this trick. Remember again it will be mentioned as a on. Then how when it will be the unique solution? What is the meaning of the p gamma is you have to find the value of p. That means find the value of the capital P at this curve gamma. On this curve gamma, you can find this value of P. Similarly, Q and so on. This the Q naught dash is the derivative of this point. Whenever they are not equal, then you can see the unique solution. Whenever they are equal, either we call as a no solution or infinite many solution. Then we have to check about the third case. That is the value of the R at this curve divided by the derivatives of the Z components. Whenever they are not equal, then we call it no solution, otherwise infinite many solutions. If you are new to my YouTube video, you can scan and join my WhatsApp group. Now let's start with this first question. Your always first target is to find the value of the P, Q and R. P is the coefficient of the del U by del J x. It is my x, this is y, and right hand side is my 2u. Your target is to find the unique solution, no solution, and infinite many solution on this particular curve. So remember, this is my on the particular curve. So what is the curve on the first curve is that's x is my x. What is the y? Y is equal to x into gx, and u is my fx. Fine. Then your target is to find the value of p on this curve. This is my x. Value of the q on this curve x. Value of the r, that's the twice of u, is a 4 of x divided by the derivative of this x1, derivative of this x1, derivative of this is 2. Clearly say they are not equal, that means we will get the no solution. First option is the correct one. Look at the second. You can define the curve. X is my x, gx is equal to 1, then y is my x, and fx is my 2x here. Then you can define again the curve equation. P is my x component, Q is my y, and twice of the u is a 4x square divided by the derivative of the x component, the derivative of the curve, derivative of this. You can see all are equal, then we will get the infinite many solution. Look at the third curve. X will be my x, y will be my x into gx, x square, and it will be my x cube. Then you can define the curve P, Q will be my y, and r is twice of u. Then divided by the derivative 1, it is my 2x, it is my 3x square. Derivative of the curve clearly say they are not equal. That means you will get the unique solution. Similarly, for the fourth curve, you have a x, x square, x4. Clearly say again the this condition will be happen. So it means you will get the unique solution. So all are my right answer of this problem. Consider the next problem. Again, it's a Cauchy problem. What is my P? P is the coefficient of the x. Q, coefficient of the del u by del y. R is my 0. Now you can see the word on is mentioned. So you have to define the curve. What is the curve of this? You can write as a cos theta, sin theta. What is the value of the u? U is my x. X is my cos theta. Then you can define the equation. What is my equation? P is equal to x cos theta. Q is equal to y sin theta. R is equal to 0. Divided by the derivative. What is the derivative of the cos? Minus of sin. Sin is my cos and it is my minus sin. Clearly say they are not equal. Fine. So once they are not equal, we will get the unique solution. Whether the solution is existence for all x, it is not existence, because if you take x is 1, y is equal to 2, it does not satisfy this condition. That means solution is not existence for all x and y. How you can check about the boundedness? Now since u x comma y is given to u x, so I can substitute this value on this curve. What is the value of the u? Cos theta is a sin theta, which is my cos of t. How you can check the boundedness? I can start with the modulus value. So what is the mod of the cos theta? It is less than equal to 1. What does it mean? That means it is my bounded. So the solution is unbounded. Cancel. Solution is bounded is the right answer. B and C are my correct answer. Look at this another curve. A and B are the such that Cauchy problem is given to you. Again, your target is to find the solution on the curve and no solution, unique solution, infinite. You can choose any value of the A, say A is equal to 1, B is equal to any real number, say B is equal to 2, such that this condition hold. Fine. So this equation will be my P is equal to A, Q is equal to coefficient of Y, R is my right hand side. So since I have taken A is my 1, Q is my 2. What is my curve? So you can choose any value of the X. What is the value of the Y? 1 minus A is my 1, B is my 2. So X I have taken as a T. What is the value of the U? U is my X, X is my T. Then I can define this value, compute the value of the P at this curve, compute the value of the Q divided by the derivative 1 minus half 1. Clearly say they are not equal, so we will get the unique solution. So add a unique solution. Infinite cancel, infinite cancel. Look about the first part. Either A or B is equal to 0. So I can choose any value of the A or B 0. This is my 0. Fine. So once this number will be 0, what will happen on the curve? If A is equal to 1, then equation will be x is equal to 1. So x is my 1, y can have any value, and z is my 1. So clearly say what will happen on this case. Derivative of 1, 0. This is 0, it can have any value. Clearly say they are not equal. Again you will get a unique solution, but he said more than one solution. That means infinite many solutions. So the right answer of this problem is C is my right answer. Again, your target is to find the unique solution, more than one solution, infinite, no solution. and the word on is given to you. So you can find the value of P. P is Q, 2. Q is the coefficient of this. R is my 5. Can you define the curve? If I take X is my T, what is the value of the Y? Y is my 3T over 2. And the value of the U is my 1. Can you define the curve? That is, compute the value of the P, Q, and R on this curve divided by its derivative. 3 over 2, 0. They are equal, but they are not equal. That means it is my no solution is the right answer of this problem. You can see within the 5 to 10 second, you can solve each problem in a very, very simple manner. I hope you can like and comment on my video. Again, you needed a 5 to 10 second to like and comment on my this video. Again, this is the Cauchy problem. So what is the P? P is the coefficient of the del u by del x. Q is the coefficient of the del u by del y. R is my 0, where u is equal to g and it has a unique solution. Check whether the word on is given to you. Yes, the word on is my given to you. So then, can you define the curve on this C? X can be any number which is greater than 0 and y is always 0. Fine. So how you can define that? It's a P, Q. So because we need a uniqueness, I will check whether they are equal or not equal. So Q, P is equal to y is my 0. Q is equal to minus of x, it's a minus of t divided by derivative 1, 0. Since x is my greater than 0, so that means t is my strictly greater than 0, then these number will never be equal. Once they are never equal, that means they are my unique solution. Look at the second. Can you define the curve on this? That is my cos theta and sin theta. Fine. So again, what is the value of the P? P is my Q, Y is my sine of theta. Q is equal to minus of X cos theta divided by the derivative. What is the derivative of the cos? Minus sine. It is my plus cos, which is always equal. Once they are equal, they will not give you the unique solution. So that means this option is cancelled. Look at the third case. X is greater than 1. I can take X is my t, Y is my 1 minus t. Then can you define the curve on this? The value of the P is my Y, value of the Q is my minus X divided by the derivative of 1. Make sure the derivative of the curve, it is my minus 1. Clearly say X is my greater than 1. That means T is my greater than 1. So this number will be my positive. This number will be my negative. It can never be equal. So that will give you the unique solution. Moreover, you can take any number. Say T is equal to 2. Clearly say they are not equal. You will get the unique solution. The last option is X can be any number. Y is equal to T square. Then you can define the curve. What is the value of the P? P is equal to Y is equal to Q. Q is my minus of X divided by the derivative. Clearly say they are not equal. We can say T is my greater than 0. I can choose T is equal to 1. They are not equal. That means unique solution will be occurring. So the right answers are A, C, D are my right answers. I hope you can like and comment on this video. I hope this up to this lecture you have found a very useful tips for you. Look at this next problem. Again, the Cauchy problem is given to you. P is equal to coefficient of the del u by del y. Q is my minus of R. R is equal to 0. Then again, your target is to find the uniqueness. No solution, infinite many solution. But you can see what is the meaning of that. They are finding, this is the initial curve. They are curve finding at the point S. X is my cos of S, Y is equal to sine of S, and Z is my 1. So then you can find the solution. What is the Q? P is equal to Y is equal to sine of S, Q is equal to minus of X, R is equal to 0. Divided by the derivative. What is the cos derivative is? Minus of sine. Sine is my cos, 1 will be 0. Clearly say they are equal. Fine. So that means unique solution will not be occur. So uniqueness will be cancelled. But whether they are equal or not equal. If they are not equal, we can call as a no solution. If they are equal, we call as the unique solution. But you can see about that 0 by 0 is undefined. So that means you are unable to identify. So in that case, once you are able to case that you are unable to make a decision, then you have to apply the Lagrange equation. Dx, dy and dz. The value of the p, value of the q, value of the z. Now since this is 0, so one solution is my C1. From these two equations, if you integrate them, if I cross multiply, x dx is equal to y into dy. If I integrate them, you will get x square plus y square is equal to another constant. Then we can define the function phi as one function which is equal to this second function. Make sure student, you can also write this one is phi of z is equal to x square plus y square. That's on your choice. But my advice is, because z is my dependent variable, z is my dependent variable, try to write z away from this phi. Fine. So then my there is no issue. You can write this equation as well. Then we can compute this value on this condition of the initial curve. That will be cos square plus sine square 1, which is 1. That is a constant. That means this is hold for all s greater than 0. But what is the s? S has infinitely many values. Once s has infinitely many value, this has infinitely many solution. So that means no solution cancel, infinite many solution. He said finite many solution. So D is my right answer. Don't forget to like and comment on this video. Again, they are talking about the unique solution, infinite many solution. What is my P? P is equal to 1, coefficient of the del U. Q is equal to 1. But make sure whether the word on is given to you in the statement. No. That means they are talking about find the solution on whole the curve, not on the particular curve. So then you have to write the auxiliary equation. That is a Lagrange equation. Dx, dy, value of the P is 1, Q is equal to 1, R is equal to right hand side is 0. Fine. So now from the first and second equation, we will get x minus y is equal to constant. And since remember, whenever the right denominator is 0 of anything like of xi, then the solution will be my xi is equal to constant. In this case, it's my u is equal to constant. Now these are my two characteristics curve. Now clearly say the second option. The family of the straight line is my characteristics. Yes, this is my straight line. Fine. So this is the second option is the correct option. Now your target is to write this function in terms of the phi, because u is my dependent variable. I can take an u outside the phi. Then your target is to find the value of phi. I can substitute this number. X will be my x, y will be my 0, u will be my 0. So that means phi of x is my 0. What is the meaning of that? Phi is my 0 function. So I can substitute what is the phi of x minus 1? 0. That means u of x comma y is my 0. Fine. Now what does it mean? This is the 0, that's always true. So that will give you the unique solution. Solution vanish at, so that means what is the value of the u2 comma 1? Again 0. So yes, it's also fine. Infinitely many solutions. Remember, your solution is u is my solution. Fine. X comma y is not my solution. U is my solution and u is the uniqueness solution. So fourth option is the cancel. A, B and C are my right answer of this problem. Look at this another curve. Now look at this another one. Again, you can see the options are one solution, two solution. That's again. But what is the P? P is the coefficient of the ux. Q is the coefficient of the del u by del t. 1. R is 1. Now your target is to find the one solution, two solution, infinite. Check whether the word on is given to you on this statement. Up to this statement, no. That means you can never apply the curve formula. That means you have to start with the Lagrange equation. Dx is here is the two variable is dt, dependent variable is my du. What is the coefficients? u 1 1. Clearly say if you take the last two equations, this will give you the t minus u is equal to constant. This is the first solution. If you look for the first and second solution, it will give you this. If you integrate them, it is u square by 2 plus constant, or I call it as a u square minus 2x is my second constant. Fine. I can write the function phi because both are my dependent variable. So I can take u square on the right hand side. Then I can apply the initial condition. What is my initial condition is? What is the value of the small t? Is a small t. U is my, this is my u, t over 2. This is t square by 4 minus 2t square by 4. That means phi of t by 2 is minus t square by 4. So always take any of the new variable, say a is equal to t by 2, then your function phi is minus t is my 2 of a. If you substitute, 4 will be cancelled. So my function will be, because your target is to find the value of phi, so phi function will be minus of x square. Substitute this value. Phi of t minus u will be minus t minus u whole square, which is u square minus 2x. Now you can open this. I can take on this right side. It's a twice of u square minus 2 of ut plus t square minus 2x is equal to 0. Now my target is to find the value of u. It's a quadratic equation. So u will be minus of b plus minus b square. So b square will be 4, sorry, it's a 2 times t. What is the b square is? 4t square minus 8 plus 16x. So that will give you 16x minus 4t square divided by 2a. So now it has a plus minus sign. So that means you will get a 2 solution. Only one solution cancel, 2 solution possible. Because it does not involve any of the constant, so infinite many solution cancel. Now what is given to you that for the last case? Solution none of which is differentiable on the characteristics base curve. What are the characteristics base curve? These are the characteristics curve. Fine. Or because this will satisfy this, this is my characteristics curves. So I can check about this differentiable. I can differentiate either with respect to x or with respect to t. So let's firstly with respect to t. 1 over 4 outside, 1 over 2, 16x minus 4t square into 16. Clearly say at this curve, when you substitute x is my 16 into t square by 4, t value will be my t. So clearly say this number will be goes to the 0. So that means this number will goes to the infinity. Once this is infinity, it means this is my not differentiable, and none of which is differentiable. Yes, this is my correct answer. So B and D are my right answer. Again, if you differentiate with respect to the t, again you will got as infinite. Now look at this another one. They are again talk about the uniqueness, no solution. But again you can see the word on is not given to you. Fine. So then you have to firstly find the p. P is the coefficient of the del u by del x. Q is the del u by del t. R is equal to x. Then write the auxiliary equation dx, dt, and the dependent variable is my u is a d of u. What is the p? Q, x. Fine. Then how you can solve that? From the first two cases, if I integrate them, it's a log of x, that is log of x is equal to t plus say log of c, or I can write as x e raised to power minus of t is my first constant. Look at the is a x. Look at the first and the last case. I can solve them. You will get u minus x is my another constant. I can define the function because u is my dependent. I can take u on my right hand side. Fine. Then apply the initial condition. T will be my 0, x will be my x, e raised to power 0, 1. U is equal to 2x. 2x minus x is x. That means identity function. So I can substitute this value. It is x e raised to power minus of t, u minus. So can you find the value of the u? u will be x into 1 plus e raised to power minus t. That is a unique solution. So no solution will be cancel, more than one solution cancel. Unique solution u approaches infinity as t tends to infinity. So what will happen as t tends to infinity? This value goes to the 0, then u will tends to the x. What is the range of the x? The x varies from the 0 to 1. It can never goes to the infinity. The first option is cancelled. Only last option is the rest behind is C. How? As t tends to infinity, u will converge to the x. The solution bounded. So we can check about the bounded. So what is the mode of u is as t tends to infinity, it is my mode of x, and clearly say what is the mode of x. It is my less than equal to 1. That means it is my bounded. So the C is my right answer of this. Don't forget to like, share and comment on my video. I hope you can support my videos to get is the easier way. Again, it's a Cauchy equation. P is the coefficient of the del u by del x. Q is my 2. R is my 0. Fine. Then again, they are not talking about the initial conditions. So you can start with this. Here is the dependent variable y and this is my du. Substitute this value 1, 2, 0. Since this is my 0, one solution is my u is equal to constant. From these two cases, I can integrate them. 2x minus y is equal to second one. I can define in terms of the phi because u is my dependent variable. I can put on the right hand side. Substitute this equation. X is my 0, y will be my y, u is my minus 4 e raised to power minus. I can take a is equal to minus y. So this function phi of a is 4, y is equal to minus at a. So it is minus minus plus of 2a. Substitute this value in this given equation. It is 4 twice of a. A is my 2x minus y, which is equal to u. This is my required solution. Now your target is to find the values at x is 1, y is 1. What is the value of the u? 4 e square is my right answer of this problem. You can see how many seconds you are needed to solve the problem. Hardly a 10 to 15 second time. Don't forget to like and comment on my video. Let a is the fixed number. So let's say a is equal to 1. Consider the first order partial differential equation. What is my p? P is the coefficient of x, 1, q, 1, r, 0. Then bounded, they are talking about this solution. So I can start with this dx over a, d is a t, dt over 1 and du over 0. So one solution is my 0, fine. Another one is x minus t is equal to constant. So I can also call as a C1, C2. So therefore solution is x minus t is equal to constant. Apply the initial condition. It will give you phi of x is equal to u0 of x. So therefore I can substitute this value u0, x is my x minus t is equal to u. That is my required solution. That is, you can say u of x comma t is my u naught x minus t. Now look at the options. There exists a bounded function u, then the u is my unbounded. We can start with this. What is the mode of u? So u naught x minus t. Now since u naught is my bounded, it is less than equal to some k. That means u is my bounded. So if u is bounded, it is unbounded. This option is my false. S1 is true. S1 is true is my wrong state. Now, if u0 vanishes for my S2, if u0 vanishes outside the compact set, what will happen? If u0 is my 0, then u of xt is also 0. Then there exists a compact such that u is also vanish. That is my true statement. So S2 is my true, S1 is my false. So D is my correct answer. Okay, look at this another one. Which of the following again is a Cauchy problem? P is my 1, coefficient of the day. Q is my del u by del y. R is my 0. Then I can start with the dx, dy, du. P, Q, R. So since du by d 0, so first constant is my u. From the first two case, I can integrate them. It's a x cube over 3 minus 3y is equal to constant. I can define in terms of the function because u is my dependent variable. I can put on the right hand side. Then apply the initial condition. U x is y is 0, u is my e raised to power x. I can take a is my x cube. So therefore, phi of a is a raised to power 1 over 3. Then I can substitute this value in the phi function. So phi of a is e raised to power x cube minus 3y raised to power 1 over 3 is my function u. And this is the required C is my correct answer of this problem. You can see how many seconds you are needed to solve the problem. Hardly a 10 to 15 second time. Again, it's a Cauchy problem, but make sure this is not on the right hand side. So I can make this on the right hand side. So this becomes my 1 minus u. Can you define the P? P is the coefficient of the del u by del x. Q is my del u by del y. R is my 1 minus u. Make sure R must be on the right hand side. Then dx, dy and du. Fine, because they are not talking about the uniqueness, no solution and so on. P is my minus x, Q is my 1, R is my 1 minus u. If you look about the first two solutions, then it will be my minus log x is y plus log of c, or I can put in this side, I can say e raised to power y is equal to constant. Fine, this is my first solution. How you can see, I can return this is xy is equal to y, or xy is equal to e raised to power minus y, or I can say xy is equal to c. This is my one solution. Can you find the other solution? You can see I can solve these two part. What will happen if you integrate them? It is a y, it is minus log 1 minus u into log c, or I can say 1 minus u over e raised to power y is equal to another constant. Fine. I can say it's a e raised to power minus y is 1 minus u of c, or I can say this is my second constant. Now once you can get the two constant, I can write in terms of phi x e raised to power y, which is 1 minus u e raised to power y. Apply the initial condition u x comma 0. So phi e raised to power 0 1, u is my sin x. So this is my 1 minus sin x into e raised power 0 1. So therefore I can substitute this value phi of x 1 minus sin x, x is x e raised to power y, 1 minus u e raised to power y. Now your target is to find the value at x is equal to 0, y is equal to 1. Substitute this number, x is 0, that is my 0, it is 1, e raised to power 1 is e. So 1 over e is 1 minus u will be 1 minus e. So A is my right answer of this problem. And if you noted that whether the paper year is 2022, whether it's a 2020, whether it's a June 18, whether it's a June 25, I have used the same approach. Fine. So whether you are attempted any question, you have to apply the same approach. You will get the solution within the 10 to 15 second time frames. Don't forget to support my videos by liking and sharing. Which of the following are the solutions? Again, the right hand side is non-zero, so I can put them as minus u. Again, it's a Cauchy equation. So ux e raised to power minus of t, q coefficient of the del u by del t, r is my minus. Once you know that this is a Cauchy equation, I can solve the same equation by the same manner. E raised to power minus of t dt over 1 and du over minus u. Clearly say from the first equation, I can say this is dx is equal to minus e raised to power minus of t. If I integrate them, it will be x. It is e raised to power minus t plus constant, or I can say x minus e raised to power minus t is first constant. Similarly, from these two cases, if I integrate them, it will be my minus log of u into log of c, or I can say e raised to power minus t is equal to uc, or I can say u into e raised to power t is constant. Now, based on this, I can write the function phi. Because u is my dependent, I can put on the right hand side. Fine. Now you can see about the initial condition. Initial condition is my u x comma 0 is x. So x value will be x, t will be 0, e raised power 0 is 1. U is my x, e raised power 0 is 1. Now I can take a is x minus 1, phi of a, what is the value of the x is? A plus 1. So I can say whatever the phi of something is, a plus 1, x minus e raised to power t plus 1 is u e raised to power t. Can you find the value of the u from this case? E raised to power minus of t, x minus of t plus 1 is the right answer of this problem. So last option cancel, x minus e, but I need a e raised to power minus t also. Correct option. This is a wrong option. B is my correct answer of this problem. Okay, look at this another one. Okay, look at this another one. Again, it's a Cauchy problem. So what is my P? P is the del U by del X. That is a U. Q del U by del T. R is 0. Then which of the following will give you again? They are not talking about the uniqueness. So let's start with this Lagrange equation. Always remember, whenever you have a Cauchy problem, always start with the Lagrange equation if they are talking about the solution. This is del du. U 1 0. So clearly say du by dt is 0. So that means u is equal to constant. Fine. Then if I take first and the last one, again give you u is a constant. So I can, how you can solve the first two equation, because I need a x and t only. So since u is my constant, I can substitute this value constant here, c1. Fine. So if you integrate them, you will get x minus c1 of t is my another constant. Or again, I can say x minus ut is my constant, because u is my c1. Now I got a two constants, so I can define the function phi. X minus u of t is equal to u. Apply the initial condition. Phi t is equal to 0. U will be my u0 of x. Substitute this value given equation. So you will get u0 x minus ut is equal to u. Fine. Now let me clear this. So therefore, what is your solution is x comma t is u naught x minus ut. This is my solution. Now read the statement. Which choice of the following function u0 which give a continuously c1, that's a continuously differentiable function for all x and t strictly greater than 0. So you can choose any one. Let's say firstly I can choose the D option. So u naught is my 1 plus 2x. So that means u is equal to 1 plus twice of x. Can you find the value of the u? So clearly say u plus u is 1 plus 2x and u will be 1 plus 2x over 1 plus 2t. Since I need a solution, so that means this limit, that means the u must exist. So when the u will be existence, when the denominator is non-zero. So clearly say this is my non-zero because t is my greater than 0. So yes means that's the solution exists. So therefore D is my correct option. Look at the C. If u0 is my x, then from this case, if this is my x, then x is my x minus ut. Can you find the value of the u from this? This is x over 1 plus t. Again, you can see this is my existence for all x and t is my greater than 0 because this number is non-zero. Look at the second option, 1 plus x square. It is 1 plus x minus ut square. Can you find the value? Let me open this bracket. 1 x square plus u square minus ut of x. This is the quadratic in u. I can write in the quadratic form. This minus 2x t plus 1 into u 1 plus x square. So when it will have a solution, when the discriminant should be greater than equal to 0, fine. So that means b square plus 4xt minus 4ac minus 4t square minus 4x square t square should be greater than 0. So that number will be cancel. So 1 plus 4xt minus 4t square is greater than 0. Does it hold for all x and all t? No, because if I choose x is my 0 and t is my 1, it satisfies this property. So then what is the value of this? Minus 3 is not greater than 0. So this option is cancelled. Similarly, you can do this part for the first option. What is the first option is 1 over 1 plus x minus ut square. Again, you can simplify this or you can choose any value. Let's say x is 0, t has any value, then again you will see this solution is not differentiable. Moreover, you can see it must be have a continuously differentiable function. So it will not be differentiable at that part. So therefore the right answers are C and D are my correct option. Consider the following partial again this is a Cauchy equation. P is the coefficient of the x, Q is the coefficient of the del u by del x, R is my 0. So let's start with the Lagrange equation, dx, dy and d of u. 1 x 0. One solution is my u is equal to c1. Second is I can solve this x square minus 2y is equal to constant. So I can write in terms of the phi x square minus 2y is equal to u. Apply the initial condition, x will be my x, y is equal to 0, u is equal to ex. I can choose a is equal to x square. Then your function phi is my e raised to power plus minus root a. Fine. Now substitute this value. Your equation will be e plus minus x square minus 2y is my u. Now look at the first part, 2 comma 1. What is the value of the 2 comma 1? Plus minus 4 minus 2, that is a root 2, but it's a square. Half 1 comma half 1 minus 1 e raised power 0 plus 1 minus of 2 plus 1 minus of 2, that's a 4, and by 2 square is 4 minus of 2, that is plus minus root 2. So minus 2 is also possible and plus 2 is also possible, but you can see, just wait, whether the both answers are correct or not. You can see about that. This is my solution. Fine. Which case will satisfy this part? When I take y is equal to 0, this one will be e raised to power plus minus x. But we need only positive x. That means this solution is defined only for the positive x. So that means this solution is defined only for the positive x. So once they are positive x, that means minus of root 2 will be cancelled. This is my positive x is the right answer. So B and D are my right answer. Clear? It's a plus minus, but the minus sign is not satisfied by given condition. So therefore, B and D are the required. Again, it's a June 2023. Again, you can see it's a June 23. It's a September 22. I can again solve the same approach. Can you find the P quickly? P is my U, Q is my 1, R is my 0. Write quickly like auxiliary equation. du dy over 1 du is equal to 0. So clearly say u is equal to constant. Fine. Since u is my constant, I can say u is equal to dy. If you integrate them, x minus c1 y is equal to constant, or x minus uy is equal to constant. I can write in terms of the phi x minus uy is equal to u. Apply the initial condition, phi y is equal to 0, u is equal to x, u is equal to x, y is equal to 0, x is equal to x. So that's an identity function. I can apply this one. So x minus uy is equal to u. Can you find the value of u? X over 1 plus y is the solution. Now your target is to find the value of 2 and 3. So that means 2 by 4. 1 over 2 is my right answer. Look at this another one. It's a June 2023. Again, you can see P is my 1, Q is my 1, R is my e raised to power u. So let's quickly write the auxiliary equation or Lagrange equation. This is my du over e raised to power. From the first two equation, I can say x minus y is equal to c1. From the last two equations, I can say y e raised to power minus of u is another constant, because if you integrate them, it is y, it is e raised to power minus u over minus 1 plus constant. Sorry, it is my y plus e raised to power minus u is constant. Then I can write in terms of the function x minus y is y plus e raised to power minus u. Apply the initial condition. X will be my x, y is equal to 0, u is equal to, this is my u is equal to 1. It is 1 over e. That means a constant function. So that is a phi of something is a constant function. Fine. So this is y plus. Can you find the value of the u from this? Minus of y is e raised to power minus u. So that will give you u is minus log to the base e 1 over e minus 1. That is my solution. Now look at the first option. Half 1 by 2e 1 by 2e log of e 1 over e minus 1 over 2e. It is not 1 because it is not a e. Fine, it's a half of e. So that means the first option is cancelled. Look at the second option. U of x. Can you find the partial derivative with respect to x? Since it is independent of x, so partial derivative is 0. So partial derivative is 0. So then it means at each point, the value is my same. Now look at the third point. That is a partial derivative with respect to y. Can you find the partial derivative with respect to y? It's a log. So minus 1 over e minus of y into y will be 1. So that is e over 1 minus ey. That is my partial derivative of u with respect to y. Then your target is to find the value of 1 over 4e, 1 over 4e. What is the value of this e? 1 minus 1 over 4. That will give you 4 over 3e. So that option is cancelled. Look at the fourth option. Compute the values at 0 and 1 over 4e. So it gives you e 1 minus 1 over 4. That gives you the 4e over 3. That means fourth is the right answer. So B and D are my correct answers. Kindly support my video by liking and sharing. Again, it's a Cauchy equation. So P will be my 1, Q will be my 2, R will be my 0. I can write the quickly solution. dy is 2, du is equal to 0. So clearly say the one solution is u is equal to c1. Second solution I can obtain as 2x minus y is equal to c2. Phi of 2x minus y is equal to u. Apply the initial condition. Phi of x will be x, y is equal to 3x plus 1, u is my sine x. Fine. I can say this is minus x minus 1 is equal to sine x. I can take a is equal to minus x minus 1. So my solution is phi of a is, the value of the x will be minus 1 minus a. So therefore this solution is my sine minus 1 minus of 2x minus minus plus 3x minus minus plus 1, which is of, is it wrong? Sine of a is sine of this. No, sorry. I have to substitute at this point. Fine. So your solution will be 2x minus y. Minus 1 minus 2x minus y is my u. That is the solution of my u. Okay, look at the second part is the same equation is given to you. Now they have the different value of the initial condition. Again, my solution will be same. Now instead of the u, this is my v. Fine. Now apply the initial condition. Phi of 2x, v is my sine x. I can take and this number is my a, then it will be my sine of a over 2. Substitute this value at point. So you will get v is sine 2x minus y over 2. Then s is my closed interval. U changes, v changes. So let me clear the screen. I can write the only solution. Fine. Now my solutions are u and v are defined to be this manner. So I can copy this screen. This is my u. This is my v. Now let s is my closed interval of 0, 1. This is my s. This is my s. This is my 1. This is my 1. U changes the sign in the interior of the s. That means if I pick any value in the interior of the s, particularly in the interior, so half and half, fine, half and half. If I choose half and half, what is the value of the u? Half and half. So that means sine minus 1. Okay, I can do little bit more easier calculation. I can take negative as a common. Then this is plus 1, this is plus 1, this is plus 1. So since this lies in my first quadrant, fine, and this number is always positive, so it means u is always negative. So inside the s, u of x comma y always negative, but he said it changes the sign in the interior, but in the first quadrant this is always positive, so you can never change the sign in the interior. V changes sign in the interior. You can see if I choose any coordinate, let's say in the interior, so let's say at this point, or how you can check about the interior, I can draw the graph. The best way is I can draw the graph where it will change the sign. When the v will be 0, I can draw the graph of y is equal to 2x. This is the graph of the y is equal to 2x. Fine. So I can choose any point of this, say 1 comma 0, or any point here. What is that point is half comma 0, or you can see there is no need to draw the line. Take any point inside it, half comma 0. What is the value of the v at half comma 0 is 1 minus 1 is a sign, half is a positive. If you look about at this point, it's a 0 comma half. Fine. Or you can take as an inside point, say any point inside this. So v at the point 0 comma half, it will be minus sine of 1 by 4. This is which is less than 0. That means it changes the sign. Or you can choose any point in this case. In this case, x is greater than of the y, so this number will be positive. At this point, you will get as y is my maximum, x is almost 0, so this will be negative. So yes, it will change the sign. Otherwise, you can choose any two randomly point. Now ux is equal to vx along the line. So let me clear the screen. Fine. When u and v are same, when 2x minus y over 2 is equal to minus 1 minus 2x minus y. Fine. So you can see if I solve this, it's a 4x minus of 2, sorry, 4 and 2, 6x. It's my minus of 2, it's a minus of y plus 1 is equal to 0. So can you draw the graph of this? When y is equal to 0, x is 1 by 6. X is 1 by 6 at this point. When x is equal to 0, y is equal to, is it true? Sorry, it's a minus 2. Just wait, 2x minus y is minus of 2 minus 4x minus 2y. 6x minus y plus 2 is equal to 0. Now draw the graph when y is equal to 0, x will be minus 1 by 3. Fine. X will be 0, y is equal to plus of 2. So x will be plus of 2, minus of 2. Is there any error? No, I think that there is an error. It is a negative. Let me quickly do the again. I think I quickly do that. Let me firstly find the value of the u. Find what is the u is. This case, if I apply the initial condition again, it will be my minus x minus 1 is my sine x, and phi of a is my sine of minus 1 minus a. So my solution is u is sine minus 1, a will be minus 2x plus y. It's a plus y. Fine. Or you can say sine of y minus 2x minus 1. Then I can again draw the graph of interior region S. Now I will again check it. Now u changes the sign in the interior of the S. So take any point inside it, or you can draw the graph of this. You can see when the sign value will be 0, when this number will be 0. Fine. So once it will be the 0, it's a straight line. Y is equal to 1. X will be my minus half. So you can draw the line equation of the u is this one. So clearly say it bifurcate S only in the one region. So you can choose any point in this S. Let's say half comma half. What is the value of the half comma half? It is my sine half minus 1 minus 1. It is my less than 0. You can choose any number, say 1 by 4, 3 by 4. Again you can see 3 by 4 minus 1 over 2 minus 1. Clearly say it is my 4 will be the LCM, 3 minus 2, again it's a negative, less than 0. So that means in this region, the value of the u is always negative. That means there is no change in the sign. Now look at the v. Again, now v will be my this graph. Now v will change the sign. So we will see when it will be the change in the sign. V will be fine, because if you take any point near to the x-axis, then y is approximately 0, then it's a positive. If you choose any point on this line axis, x 2x minus y is less than 0, so it will be the negative. Yes, v will change the sign. U and v are same. So when it will be the same, when this number is same as 2x minus y over 2. So that means 2, 4, 6x 2 minus 3y plus of 2 is equal to 0. Can you draw the graph of this? When x is equal to 0, y is equal to 2 by 3. When y is equal to 0, x is minus 1 over 3. So your graph will be this one. And clearly say on this line, this is the dark portion. What does it means? On this portion, my u is equal to v. So yes, u is equal to v along the line in the S, and this is the portion which is in my S. So yes, B option is the correct option. Look at the last option. V vanish along the line in S. So can you draw the graph of line? What is the line of this in the S? 1 and 1. So y is equal to x is 0. This is the line of this, and clearly say on this line, this is the portion of the S. On this line, y is equal to 2x. This is a line in the S. V is equal to 0. Yes, this option is the correct option. So B, C, and D are my right answer of this problem. Look at this another problem. The solution of the partial differential equation again, P is equal to minus x, Q is equal to 1. R is, because this is not in the right hand side, I have to make in the right hand side. Write the auxiliary Lagrange equation. This is minus x, d of t is my 1, and d of u is u minus 1. From the first two equation, I can say x e raised to power t is my constant. From the last two equations, I can say it's my t is equal to log of u minus 1 into c, or I can say u minus 1 e raised to power minus t is my constant. I can write in terms of the function, this is u minus 1 e raised to power minus t. Apply the initial condition, phi e raised to power 0 1, u is my gx minus 1 e raised to power 0 1. So substitute this value in this case. So g of x e raised to power t minus 1 is u minus 1 e raised to power minus t. So can you find the value of the u? U is e raised to power t, g times x e raised to power t minus 1 plus 1 is the right answer. So this option is wrong. It's a 1 minus, but we need a plus 1. 1 minus the, if I take a minus common, but I need a e raised to power plus of t. It's a minus of t. 1 plus e raised to power t, fine. 1 minus g, but I need a g minus 1. This option is cancelled. This is 1 minus e raised to power minus t. So that means none of this is the correct answer of this problem. Actually, I think this should be the negative sum. Look at this another one. Again, this is the Cauchy equation. U is the coefficient of the ux minus of u. Q is my 1. R is 0. So now you can find this solution. Minus d of t 1, d of u 0. So one solution is my C1. Fine. Since u is equal to constant, I can substitute this number is my minus of c is my dt. I can solve this equation. It is x plus c1t is equal to another constant. That means x plus ut is equal to constant. I can write in terms of the phi, x plus ut is equal to u. Apply the initial condition. Phi of x is u is my x. That is the identity function. I can apply this condition is of. Can you find the value of the u? U is x over 1 minus t. Solution is defined for all t less than 2. Wrong, because it is not defined at 1. What is the meaning of the breaking point? That means solution will goes to the infinity. Solution exists for all t less than 1 satisfied. Breakdown at 1, fine. Solution exists for all t less than half satisfied. Breakdown at 1 by 2. But whenever t is 1 by 2, then u will not goes to the infinity. So this option is cancelled. Solution exists for all t. That's wrong because it is not defined at t is equal to 1. So C is my right answer of this problem. Look at this another problem. P is my u, Q is my y, R is my x. Write the auxiliary equation. Du dy over y du by x. Now in this case, your target is not to find the solution, but make sure whenever there is a curve, think about how you can make a u square minus x square. If I make this term, if you integrate them, it is a u square by 2, x square by 2. So that means I can start from this term. If you look about these two equations, then clearly say this is my term. If you integrate them, u square by 2, x square by 2 is my one constant. Fine. How you can make the x plus y? The only way you can make the x plus y is either you can do like this manner. Fine. So I can start with the dx plus du. Fine. Dx plus du is a u plus x, and the remaining one is, now clearly say if you integrate them, it will be my log of u plus x. It is my log of y. I call as a log of c. So clearly say I can say y over u plus x is my another constant. Fine. Now you have the two solutions. You can write the solution in the form of phi of one part is equal to second part, or you can also write the solution say f of the first function comma second function, and that is my first part. You can see how you can make the second part. If I write this function as u square minus x square is phi of second part, then clearly say u square is 1, g instead of the phi is my g. U square plus x square is a 0, but we have a u square plus x square. x plus y. How you can make them as x plus y? You can start with the dx plus dy. What is the x plus dy? Fine. The remaining one is, so can you separate the variable? It is not possible. You can separate. So that means this is the not right answer. A and B are the correct options. The solution of the Cauchy problem. Again, P is my x, Q is my y, R is my z. So then dx over P, dy over Q. In this case, the dependent variable is z. Now, if you look about the options, your target is x in x square. That means you are approaching like this manner. So I can start with x dx, y into dy. It will be x square plus y square. Now clearly say you can separate the variable. How you can integrate them? If I multiply by 2 and divide it by 2, what is the integration of this portion? It is log of x square plus y square. Fine. This is my log of z into c, or I can write it as x square plus y square is z into c is the, so c is my constant, so x square, and okay, c, how you can find the value of c? I can use this condition, x square plus y square is 1, z is 1, so c will be 1. So therefore my solution is z is of this. This is the first method. Second method is, instead of writing this, you can also start with the phi. You can find a function phi. How we can do that? Clearly say from the first two case, if I integrate them, it's a log x is equal to log y. It's a constant. From the second two cases is my this case. Now since z is my dependent variable, I can put z on the right hand side. Apply the initial condition. Now since initial condition is the polar form, I can write this easiest manner this way. Z is my 1. Substitute this value, x over y cot theta, y over z sine theta. If I take a is equal to cot theta, then what is the value of the a? So if a is equal to cot a and 1, this is 1 plus a square. So sine will be 1 over 1 plus a square. So substitute this value of the phi. So phi of x over y is x square over y square, which is y over. So you can take the LCM, y will be cancelled out. It is y square plus x square is z. Again, you can see D is my right answer. Look at this another function. F is a function such that first partial derivative, second partial derivatives are same. So definitely the function could be of this form, or it could be of this form, or it could be of this form, or you can say it could be of this form. These are the only possibility when the partial derivatives are same, or in general you can say f of xy is a function of any x plus y form. Then if I choose this example, firstly f of x plus y, does it true? No, because if I choose the 1 comma 2, clearly say this is a non-zero. Again you can see x comma y is not equal to minus y comma x. Now whenever phi is my phi of x plus y, that means this is my symmetric function, because f of x comma y is f of y comma x. So look at that, the first point, the left hand side will be 0, this value and this value are always same by the given condition. So if you take the common, y will be cancelled, x will be cancelled, so 0 is equal to 0, always true, it is true. F is constant along the line y is equal to x is equal to minus y. I can substitute this value. What is given to you? Phi of 0. Phi of 0 is my constant function. So yes, f is my constant function. So right answers are A and B are the right answers. Again, it's a Cauchy equation. So P is my x minus y, Q is my y minus x minus u, R is my u. So dx over x minus y, dy over y minus x minus u, du over u. Now how you can solve them? We will look about the options. It is x minus y plus c. How you can make them x minus y plus c? I can start from this case. Fine. What is that? Dx minus dy. If you subtract them, it will be my 2x, it will be my 2y, and it is my minus minus plus u. Fine. Plus of u. So it's a twice of u. Fine. And you can see clearly say if you integrate them, this will be my half log of x minus y plus u, which is equal to half uc. Fine. Or I can take on this half as this side. It's a log of u square. So you can see u square over x minus y plus u is my constant. Now clearly say I need a x minus y plus u into u square, but it's a division by. So this option is cancelled. Now this is a one constant. What is another? This option is cancelled. Y minus x minus u. Y minus x minus satisfied. I need a x plus y plus u. How you can make the x plus y plus u? I can add them. What is that? If you add them, y will be cancelled, x will be cancelled. This is 0. What does it mean? If you integrate them, x plus y plus is my constant. Now apply the phi condition. It's x plus y plus u is equal to u square over x minus y plus u. Apply the initial condition. X is my x, y is equal to 0, u is equal to 1. It's a 1 over. So that means phi of a is 1 over a. Then you can write the solution directly. What is my solution? Substitute this value in this case. It's a reciprocal. So 1 over x plus y plus u, which is u square over x minus y plus u. If you cross multiply them, u square satisfied, and it's a plus. So it's a, you can put on the left hand side. It's true. U square x minus y, but u square x plus y. U square x minus y. Right answer is B is my correct option. It's a Cauchy again. P is my u, q is my 1, r is my 1. So dx over u, dy over 1, du over 1. From the last two equation, I can say u minus this. From the first and the last equation, I can say u square minus 2x is second constant. So I can define the function phi u minus y is u square minus 2x. Apply the initial condition. U is equal to kx, y is equal to 0, k square x square minus 2x. I can choose a is equal to kx, then phi of a square minus 2 over k into a. So I can substitute this value. What is my a square? U minus y whole square minus 2 over k u minus y is u square minus 2x. I can open this bracket, u square will be cancelled out. So it is y square minus 2uy minus 2uk plus 2y minus minus plus 2x is equal to 0. Then which of the following problems have a solution? So I can find the value of u firstly. So u will be, these are the two coefficients of the u. Then it will be y square plus 2y over k plus 2x divided by, u will be common, 2 will be common, it's a y plus 1 over k, or I can LCM them, it's a k y square plus 2y plus 2kx divided by 2 times ky plus 1. Fine. Now look at that. It is given that they have a solution. What does the meaning of the solution is? This is existence. That means the denominator part is my non-zero. Fine. So now look at the first option. When k is equal to 0, when k is equal to 0, 1 is equal to non-zero, satisfied. K is equal to minus of 2, minus 2y plus 1 is non-zero. Is it true? It is not true, because if you choose y is equal to half and y lies in between them, this is the first coordinate of the x. This is the coordinate of y. When y is equal to half, it lies in this, the solution does not exist. Third case, y is equal to, k is equal to 4. So 4y plus 1. Clearly say it is not 0 in this domain. It is 0 only minus 1 over 4, which is not the part of 0 to infinite. K is equal to 1. Then it's a 1y plus 1 is equal to 0, which is not possible in this domain. So the right answers are A, C, D are my correct answers. Again, it's a Lagrange equation, so I can write as a dx over coefficient of the x, dy over coefficient of y square, and it's a dz over x plus y into z. Now, before solving, look at the option. I need a xy. How you can make the xy after the integration? The one way is you can take this term and integrate. That will give the log x into log y. That's a log xy. Or you can make this term x dy y dx, because this is the derivative of xy. If you integrate them, it is xy. Fine. Now, but I need a division by z also. Fine. So that means I need a logarithm part. So firstly, I can try to for this case. If I think about dx over x plus dy over y, what will happen? If you divide by x plus y, and you can see the right hand side, x plus y into z. Clearly x plus y will be cancelled out, and then you can integrate them. It will be my log x into log y, which is equal to log of z into c. So clearly say the first term will be xy over z is first constant. Fine. The first term I have made it. Clear? So the first one is xy over z is equal to constant. Now I need a x minus y. How you can make the x minus y? I can start with a dx minus dy. Fine, because it's a negative sign. You can't take as a logarithm. So let's start with the dx minus dy. It is x square minus y square. The remaining term is this part. Fine. So clearly say 1x plus y will be cancelled out. Then it will be my x minus y. It is dz over z. If you integrate them, it will be my log of x minus y. It is my log of z into c. So clearly say my second solution is x minus z, x minus y over z is my constant. So clearly say from these two equations, this one is satisfied. Fine. Look at the second part, x minus y over z. I already made. How you can make 1 over x minus 1 over y? You can see if I integrate this portion, what will happen? Minus 1 over x minus 1 over y plus constant, or I can say minus 1 over x minus 1 over y is c3. So you have this third constant. Now from this second equation and the third equation, I can write the solution in this manner. Now this is in terms of the solution. I need a one solution, this one, and one solution the z. Whether you write this or this, again it is not in the form of this one. While the last solution, I can start with the equation number 1. I can write z over xy is also the part of the constant, which is the function of 1 over x minus 1 over y. Clearly say if you multiply them, it's a xy, but it is not possible. So the right answer is A, B, D are the correct answer of this problem. Okay, again it's a Cauchy-Euler, it's a Lagrange equation, because what is the P? P is my partial derivative with respect to x. Q, small q is partial derivative with respect to z. P is my z into x. Q is my minus z into y. R is my y square minus x square. So dx over zx, dy over minus zy, and dz over y square minus x square. Now, again you can see from the option, I need a x square, y square, z square. That means I need to start from this term, then only it will be x square, y square, z square. So what is the value of the x into dx? That is x square into z. Multiply by y, y square into z. multiply by z, y square z, x square z. Clearly say this is 0, this is 0. So this part denominator is 0. If you integrate them, your first solution will be x square, y square, z square is constant. Fine. Second, I need a xy. So you have the two ways. Either you can start with this. If you integrate them, it's a log x log y, or you can start with x dy plus y dx. Let me firstly do this one. If I divide it by x, this is my z. If you divide it by y, divided by y, again it's a z. So again it's a 0. Then if you integrate them, it give you log x into log y is my constant. So clearly say xy is equal to constant. If you want to solve by this manner, again you can see x into dy. X, if you multiply this by x, it is my minus x into zy, y into dx, that is y zx. Again it will be 0. Again if you integrate this part, it will give you xy is my constant. So from these two equations, you can see the first option is satisfied. Fine. Now look at this x plus y whole square. Okay. Now think about x plus y as a one term. How you can make a term? That means you can start from this part. Fine, because if you integrate them, it will be, so I can start with the dx plus dy. Firstly, I can start with the dx plus dy. What is the dx plus dy? Z will be common. It is x minus y. And the right hand side is dz, y square minus. So clearly say if I take minus as a common, so it will be x plus y into dx plus dy, which is minus z into dz. So what will happen if you integrate them? It will be x plus y whole square over 2 plus z square over 2 is my another constant. So from this equation number third and equation number second, from these two equations, I can obtain this one. Similarly, from this C1 and C3, I can obtain this part. Now the only thing is y minus x. So I can start with the dy minus dx. If you subtract them, zy minus zx, it will be dz over y square minus x square. So I can take minus of the z common. So it is y plus x. Now one value will be cancelled out. So it will be y minus x d times y minus x, which is minus of the x z into this. So if you integrate them, it is y minus x whole square plus z square is my another constant C4. But I need only y minus x. It is not possible. So the right answers are A, B, and D are the correct answers. Look at this another one. Again, it's a linear equation. So dx over x, dy over y into u, and du over minus xy. Now clearly say, if you look for the options, your target is to find this solution, u. How you can find this solution? Again, you have to think about term. Look at that, it's a x, y. If I start with this term, firstly x of this, it will give you the xy. Fine. Xy, this is the xy u. If I say it's a xy, this is xyu. Fine. If I subtract them with the u times, now if I add them as a u times of u, so it will be this term. Fine. So now you can see I can compare with the, because the remaining term is my xy, I can take the last term. So what will happen? Again xy will be cancelled. The denominator is minus 1. What is the integration of the first part? Xy. Integration of this is u square by 2. Integration of this will be minus u plus constant. Now can you find this constant? Because my condition is given to you. So xy is my 1, u is my 25, plus 5 is equal to C. So what is my C? 10, 12, 37 over 2. So therefore, u square over 2 plus u plus xy minus 37 over 2 is equal to 0. Fine. So can you find the solution u? It's a quadratic in u. I can solve this equation quadratically. So I can say u square plus 2u plus 2xy minus 37 over 2 is equal to 0. So minus of the b plus minus b square 4 minus 4ac minus 37 over 2, then divided by 2. So now you can see when the solution exists. Solution exists when the discriminant should be greater than equal to 0. So that means 4 minus 8xy minus minus plus 474 is my greater than 0. That means 8xy is my less than equal to 78. Fine. So what is the meaning of that? Xy will be less than equal to 78 by 8. Is it true? Calculation, we can check it quickly. So 4 to your 8, 4 into 37 is I can 274. So what will happen is a 336, sorry, 39 divided by 2, 39 by 4, 39 by 4. So I just check the calculation again. What is my solution is 10, 20. Just wait. What is my solution was this plus u square by 2 plus u is equal to constant. So this is 1, 25 over 2 plus 5 is equal to c. So it is a 6, 12 plus 25. That's a 37. 37 over 2. I can take the, oh sorry, if I multiply by 2, it is only 37. Fine. Because I have taken the LCM as a 2. Then your discriminant b square minus 4ac should be greater than 0. That means minus 4xy minus minus plus 4 into 37 is greater than 0. That means 8xy is less than equal to, what is that, 37 into 4? 12, 148 plus 4 is 152. Xy should be less than of 152 divided by 8. So 7 to 14, 76, 4, 9. Fine. So that means solution exists when xy is less than equal to 19. That's condition satisfied. Fine. Now, so what is my solution is u of x comma y, which is minus 2 plus minus, this is my 152 minus 8xy divided by 2. Clearly say this function is symmetric in x and y. So therefore uxy and uxyx are same. The solution existence for greater than 19 not possible. Now you can find the value of the u1 comma 11 minus of 2 plus minus 152 minus 11 into 8 is 88. So 4 is a 1464 divided by 2. That means minus 2 plus minus 8 over 2. If you take the positive value, then it will be 6 by 2, 3. If you take the negative value, it is my minus 5. So this value is my with respect to the positive. So this value must also be occurring with respect to the positive sign. What is the 13 comma minus 1? Minus of 2 plus minus. What is that? It's a 152. 13 into minus 1 is a positive. 13 into 8. 8 here 24. 104. So it's a 256. That is 16. So if you take the positive sign, what is the answer of this? It's a 7. If you take the negative sign, it is my minus 9. So since this value occurring as a positive sign, this value is occurring at the positive sign, so both are satisfied. You can see this value is occurring corresponding to the negative sign. I will check whether u of 1 minus 1 corresponding to the negative sign is 5 or not. So what is the u of minus 1? So it's a plus of 8. It's a 160 over 2, which is not equal to 5. So this option is cancelled. A and C are the right answer of this problem. Again, this is the Cauchy-Euler, this is the equation of the Lagrange. So I can write this is x plus y into z, d of y. Same approach, start from the first question to the last question. Don't forget to like, comment and subscribe my YouTube channel. Again, your targets to x square, y square. How you can make them? I can start with the dx, dy and this. Fine. We will see is a 0 or not. If I multiply this x square into z, x, y, z. Multiply this by y, x, y, z minus y square z. This multiply by z plus x square z, y square z. So you can see it will be twice of x square z plus twice of x y z. Twice x z common, x plus y. Is it possible you can compare? Yes, I can compare this term x plus y of z. It's a twice xz, x plus y. Now you can see x plus y, z will be cancelled. Only x will be there. I can multiply 2x on the right hand side. What is the integration of this? X square by 2, y square by 2, z square by 2. It is a 2x. Integration of the 2x will be x square plus constant. So what does it mean? Y square plus z square minus x square by 2 is my constant. That's a positive sign is not possible. X square minus y square minus z square, that's the same thing. If I take it as a negative common, then I will think about this term. How you can make as a xy? Again, either you can start from this term. Look at that. If I divide it by x, it will not happen anything. Fine. So what you can do is I can check with x into dy, y into dx. What will happen? X into dy. That means x square z minus xyz. Multiply this by y, xyz plus y square z. So clearly say this is x square plus y square. I can compare this term with the, clearly say z will be common, x plus y will be cancelled out. So this quantity is x dy plus y dx is z into dz. So clearly say if you integrate them, this is xy, this is z square by 2. So z square minus 2xy is the correct option. Look at the third option. We will see whether x plus y plus z. That means we will start from this quantity. So what is the x plus y plus z? So it's xz plus xz, 2xz, yz cancel. Can you compare this term with any of these so that it will be cancelled out? It will not be cancelled out. So that means this option is cancelled. Similarly, you can see about that because I already obtained that it's a twice of xy is not a z into this. So this option is also cancelled. B is my only right answer of this problem. Okay, look at this another one. Again, it's a dx over x, dt over t and du over u plus 1. From the first two equation, I can say x over t is my constant. From the last two equation, I can say u plus 1 over t is my another constant. I can write the function. I can take an u as a outside. X over t is u plus 1 over t. Substitute the curve phi. X will be my x, t is my x square, u is my x square and t is my x square. So that means phi of 1 by x, I can take a is my 1 over x. So this number will be 1 plus a square. Substitute this value in this equation. So 1 plus x square over t square, which is equal to u plus 1 over. So can you find the value of the u? U is 1 minus 1 plus t times 1 plus x square over t square, or or you can LCM them. So u will be t square plus x square over t minus 1. Fine. Now this is my solution. Now look at the option. Singular at 0 comma 0. What is the meaning of the singular is? Solution is not obtained. So what is the limit as x comma t approaches 0 comma 0? What is the value of this? Because you can see the degree of numerator is greater than of the degree of denominator, so that this term will approaches toward the 0. So therefore what is the value of the u 0 comma 0? Minus 1. Otherwise, because as I already told you in my PY question of the continuity, you must watch about these shortcut tricks. Otherwise you can take about the path y is equal to mx and then take the limit x approaches 0, clearly say this is m square x square plus x square over mx, which goes to the 0. So that means it is well defined. The given space curve is not the characteristics curve. What are the characteristics curve? These are my characteristics curve. Fine. Once they are the characteristics curve, they are given not at 0 comma 0. Clearly say this equation is not defined at 0 comma 0. Clearly say it is not defined because the degree of the numerator and denominator are same. So it is not the characteristics curve. Yes. There is no characteristics curve passing through the 0 comma 0. Can you say about that? There is no characteristics curve passing through the 0 comma 0. Yes, you can see there is no characteristics curve passing through the 0 comma 0. The necessary condition for the initial value problem to have a unique solution at 0 comma 0 does not hold. Fine. At the initial condition 0 comma 0, that means we have to find the what is the p. P is x, q is my t. What is my curve? Curve is at the point 0 comma 0. So what is that? X. How you can say that it's not a 0 comma 0? Okay, my curve is, what is my curve? X will be x. It's t is x square, u is my x square. So x value, t value, u value. Fine. Divided by its derivative, curve derivative. So clearly say they are not same. Fine. So they are not same. So does not hold uniqueness is the, so all are my four are the right answer of this correct options. The general solution perpendicular to the surface. Again, it's a perpendicular to the surface. So, but clearly say the Lagrange equation is not given to you. You can define the Lagrange equation as a constant. That's a perpendicular equation. Can you find the constant value from this? Z square over xy. So what is the equation of this? This is del f upon del x, del f upon del y, del f upon del z. So what is the value of this? If you take the derivative with respect to z, it's a minus z square upon x square into y. With respect to y, it's a minus z square over x into y square. And this is with respect to z is twice z over xy. Now I need a x square minus y square. How you can make the x square minus y square? I can start from this quantity. Fine. So if you multiply this by x, it will be minus z square over xy. Subtract z over. So clearly say this will be 0. So what will happen if this is 0? That means x square minus y square will be 1 constant. Then x into z. What is the meaning of the x into z? I can start with the dx over dy and dz over z. If I divided this by x, so this number will be z square over x cube y, and if you divided this by z, 2 over xy. Clearly say you can never compare with any of these terms because none of them is cancelled out. So xz is not the possible case. X square and z square. How you can think about the x square and z square? So because they are the positive sign, x dx, z into dz. If you multiply this term by z, x, it will be this value. If you multiply this by z, It is 2z square over xy. So that means z square over xy. This is my, can you think about any of the term on the right hand side which can be comparable? Z square, yes, you can compare by this term. So clearly say xy will be cancelled, 1z will be cancelled. So 1z I can return this term. X z is z over 2. So now you can integrate them, x square plus z square over 2, and this integration is z square over 4, or I can divide it by 2 on the each side. So this is my z square by 2. So if you take the LCM, it's a 2x square plus z square is my constant. So 2x square plus z square is constant. This is the cancel. It's a 3x square, z square is not possible. So C is my right answer of this problem. Again, this is the Cauchy Euler. This is the Lagrange equation. So I can return this equation. Y over y is du over 0. So one solution is u is equal to C1. From this equation, you can see x over y is my another constant. So I can say here instead of the u is my z. Fine. So z is written as 5 times of x over y. Because it's a logarithm, I can take it as a modulus value. X minus y is not possible. X plus y is not possible. X plus y is not possible. Why? Because if you take dx plus dy, it is my this, it is my dz over 0. So if you integrate them, it will be this part, but it's a mod of x plus mod of y. It should be in this form, but it is not of this form. So that means your answer will be, or I can compare, either you can compare this by this quantity, then it will be log of mod x, but it is not in the form of x plus y. So the right answer is A is my correct answer. Look at this another case. In this case, the solution is already given to you. There is no need to write dx over and so on because the solution is already given. The only thing is you have to write the terms in this manner. Fine. Now find the function phi. Initial condition is this term. So x plus y is equal to 0, u is equal to 1. I need a x square plus y square. If x plus y is equal to 0, if I add scaling plus 2xy is equal to 0. Fine. So I can write this quantity is xyu is minus 2xy minus of 2u. Fine. Now apply this condition, u is equal to 1, xy is equal to minus 2xy minus of u. I can choose a is equal to xy. Then what will be your function is phi of a is minus 2a minus 2. Then you can substitute this value in the given curve. Phi is my minus 2xy u minus 2, which is x square plus y square minus 2u. So the first one is x cube, cancel out. X cube, cancel out. I have a x square plus y square. X square minus y square cancel. If you simplify them, it's a x square plus y square minus 2u common. It will be xy minus xy, xy minus 1 and minus minus plus 2. Xy minus 1 minus 2. So C is my correct answer of this problem. I hope you can like and share this video with your friends. We will see the next lecture on the limit and continuity. Till then, you can like, share and comment on videos. Best of luck students. Happy luck.